Welcome to Computer Programming, a short educational video by Tommy J. First, we will have a brief look into the history of computer programming, and then we will look at a couple of aspects in more detail. The Antikythera mechanism is an ancient mechanical computer designed to calculate astronomical positions and is regarded as the birth of programming. It was recovered at the start of the 20th century from the Antikythera wreck, but its significance and complexity were not understood until a century later. The construction has been dated to the 1st century BC. Technological artifacts of similar complexity workmanship did not appear until the 14th century, when mechanical astronomical clocks were built in Europe. The Jacquard loom, which Joseph Marie Jacquard developed in 1801, used a series of pasteboard cards with holes punched in them. The whole pattern represented the pattern that the loom had to follow in weaving cloth. Charles Babbage adopted the use of punch cards around 1830 to control his analytical engine. The first computer program was written for the analytical engine by mathematician Ada Lovelace to calculate a sequence of Bernoulli numbers. The development of computer programming accelerated from the 1750 to 1850, an era called the Industrial Revolution. In the late 1880s, Hermann Holrich invented the recording of data on a medium that could be read by a machine. After some initial trials with paper tape, he settled on punched cards. To process these punched cards, first known as Holrich cards, he invented the tabulator and the key punch machines. These three inventions were the foundation of modern information processing industry. In 1954, Fortran was invented. It was the first high-level programming language to have a functional implementation. The code is translated by a program called a compiler, which translates the Fortran program into machine language. The invention of the von Neumann architecture allowed computer programs to be stored in computer memory. Early programs had to be crafted using elementary operations of the particular machine, often in binary notation. Every model of computer would likely use a different machine language to do the same task. Later, assembly languages were developed that let the programmer specify each instruction in a text format, entering abbreviations for each operation code instead of a number. Entering a program in assembly language is usually more convenient, faster, and less prone to human error than using machine language. By the late 1960s, data storage devices and computer terminals became inexpensive enough that programs could be created by typing directly into the computers. Text editors were developed that allowed changes and corrections to be made much more easily than with punched cards. As time progressed, computers have made giant leaps in the area of processing power. This has brought about newer programming languages that are more abstract from the underlying hardware. Although these high-level languages usually incur greater overhead, the increase in speed of modern computers has made the use of these languages much more practical than in the past. These increasingly abstract languages typically are easier to learn and allow the programmer to develop applications much more efficiently and with less source code. However, high languages are still impractical for few programs, such as those where lower-level hardware control is necessary or where maximum processing speed is vital. Did you know? A high-level programming language is a programming language with strong abstractions from the details of the computer. In comparison to low-level programming languages, it may use natural language elements, be easier to use, or be from specifications of the program, making the process of developing a program simpler and more understandable with respect to a low-level language.